Hi, welcome to this year's Capstone project. My name is Sandro Silva and I'm representing Phoenix Electric Corporation. This year's project is called Fiber Optic Annunciator, which is a continuation of last year's project that the three engineers started in the last Capstone program. I'm going to talk a little bit about Phoenix Electric Corporation. We are located in Canton, Mass. We custom design and manufacture products for the electric power industry. We were established in 1973. Phoenix Electric serves the utility and in the industrial market. Currently, we have over 60 employees. The majority of the PC employees are highly trained technicians and engineers. We design and manufacture specialty products to meet customer requirements. Some of our products are aircraft reactors, custom engineered controls, specialty high voltage switchgear, and custom switchgear retrofits. Some of our services are designing and engineering, manufacturing and testing, field service, and training. One of our products is called aircraft reactors. We control power surges. They range from 400 volts to 500,000 volts. Currently, we have over 20,000 in service. Custom engineered high voltage controls, we have over 6,000 in service. These are pictures of local control cabinets. That's where these annunciators will be installed. We also do specialty high voltage switchgear designed to match older and existing equipment meeting specialized requirements. Custom retrofits. These products take a very long time to design. They're very large, and as you can see in these pictures, there's a before and then after. These projects take about a year to develop, while the others is about 6 to 7 months. Let's talk a little bit more about the project this year, Fiber Optics Annunciator. So last year was developed and simulated. This year we expect to fabricate, test, and validate the design. So this year's goal is to develop the fiber optic annunciator system that would be functionally equivalent and reliable in comparison with existing electrical circuits. Project motivation for this project is the fiber optic is immune to electromagnetic interference, EMI, safe. Fiber optic offers a much higher level of security, fewer components used, less potential for device failures, smaller physical space, cost effective. A typical fiber optic annunciator system is comprised of different components like the power converters on both sides, input 12 signals and output of the 12 signals, the fiber optic transmitter and receiver. General functions transmit and receive up to 12 alarm signals. Various fiber optic cables need to be within 3 feet or up to 30 miles apart. The fiber optic cable needs to be capable of withstand 50 kilovolts per meter. This is the master configuration for this year's project. You see the signal converter board and the annunciator board, and within you see all the components that were designed last year. And also on the bottom you have the customer interface. Mainly is just picking up the fiber from both boards or either one and transmit to the customer, which can be located very far away. So the majority of the accomplishments expected for this year Capstone project is to finalize the design of the Signal Converter PCB, finalize the design of the Annunciator PCB, fabricate and test the signal converter, fabricate and test the Annunciator PCB, finalize develop of the FPGA firmware necessary for both the signal converter and the Annunciator board, update the power converter module, prove that both boards communicate with each other, and demonstrate a full functionality of both hardware and firmware. Let's talk a little bit about the signal converter board basic functions. DC to DC converter. So we would expect to use 125 volts DC or 120 VAC, and then we need to convert to 48 volts DC, 24. Also, we need to convert to power the internals of the board, 12 volts, 3.3, and 1.1. The fiber optic interface and the FPGA to fiber optic interface design, multiple continuity checks, multiple load switches, support circuitry, mode switch, memories, connectors. The Annunciator board basic functions are basically the same as the signal converter. The only difference mainly is that we need to have a 12 LED display. Team composition and skills required. We're looking for 2 or 3 electrical engineers interested in learning about fiber optics, power industry, and PCB layout and design. Strong understanding of VHDL, knowledge in the digital and analog circuitry, design with SPICE simulation, experience, practical knowledge in FPGA design from internships on on-class projects, familiar with Xilinx Vivado or Microblaze or equivalent experience, a plus. One of the team members should be enrolled in the ELE 391 PCB design with Mike Smith, experience with C programming, UART-based command parsing and response. If you have any questions, please contact me, Sandro Silva, or Mike Smith, the consultant director for this Capstone project. If you have any questions, you're not sure, please contact any of us as well as Dr. Sunak. Be happy to answer any questions to make up your mind in deciding what project you should be taking. And I hope to see PC team very shortly.